Okay, I just graded test 25 and the results were not very good. We had a lot of C's, which I don't like to give out, and some D's. So I knew we have a problem, so I want to go over these before you have your final. I'm going to end up not counting those test grades because that was a bonus test. It wasn't in the schedule. So the only way I'll use it is if you had a lower grade, and I'll substitute that in for one of your lower grades. So I'm going to do most of the problems on the test. I'm going to skip the distance problem for now and hit some of the ones that could possibly be on the final. So number 2, you guys all guessed at this problem in your homework, and when you came to the test you couldn't guess because this one's a little bit more complicated. This one says the 70-foot rope was cut into 2 pieces. So right away you would have a larger piece and a smaller piece, possibly, but you'll find out later that one is larger than the other. When you cut your rope, no matter how big your rope is, if you cut it, this piece plus this piece is going to equal 70. So that's your first equation. Now they tell us some things about the longer piece. It says one of the pieces, so the larger piece, was 10 feet longer than 3 times the length of the smaller piece. So that's our second equation, and then we're just going to substitute in. So for L we put 3s plus 10 plus s equals 70, and then we solve it. 4s equals 60, s equals 15 feet, and that would mean that the larger, I'm going rather quickly on this one, would be 55 feet. Alright, you have to make your 2 equations when you do these kind of problems. Guessing works sometimes, but not when it gets this complicated. Okay, the consecutive integer problem, most of you actually got that one right, so I'm going to skip that for right now. Let's skip down to number 5. This one says Jen rolls a fair die 6 times, and each time she rolls a 2. What is the probability on her next roll she will roll a 6? Well, if you have a die, okay, the probability of rolling a 2, let's see, a 2 or any number is always 1 out of 6. Even if the previous time, if you rolled 2s every time, it's still going to be 1 out of 6. There's 6 sides on your die, and when you roll it, there's 6 possible ways it could land, but there's only one way that you could get a 2. So this one's 1/6. Now the one I'm most concerned about on the test is number 6. We had right triangles, and we were supposed to use the Pythagorean theorem to solve these. So you had 5, a, and 13. What most of you did was you disregarded that a squared plus b squared equals c squared, that these 2 parts are the legs and this part is the hypotenuse. Remember, the hypotenuse is the side opposite the right angle. So when you're doing it, it's leg squared plus leg squared equals hypotenuse squared. Most of you did 5 squared plus 13 squared equals whatever variable was left. It doesn't work that way. You have to do the leg, so it'd be 5 squared, plus another leg equals the hypotenuse squared. The hypotenuse always goes on this side of the equal sign. You can't just do it the easy way where you have a number equals c squared. It doesn't work like that. So we square it, 25 plus a squared equals 169. A squared equals 144. And you would take the square root of both sides. Normally we would say plus or minus the square root of 144. But it's a length, so we only have the positive value, so we get 12 for A. Let's look at a couple more of these. I'm trying to go fast because I know these videos are hard to watch. So here's another oddly shaped right triangle. I didn't make it the same way as the picture, but you get the point. We have 5 is your hypotenuse, 4 is a leg, and you need to find this side right here. So remember, it's leg squared plus leg squared equals hypotenuse squared. Whoops, I wrote the answer to that. Hypotenuse squared. So we're going to get 16 plus b squared equals 25. B squared, 25 minus 16 would give us 9. So if we take the square root of both sides, we get b equals the square root of 9. B is going to be 3. And let's do the last one. This is C. I'll draw the triangle the right way this time, even though it doesn't look nice. 8, 17, and 6. Same thing. Whoops. One of these is a letter. That should be a C. So, same thing. Leg squared plus leg squared equals hypotenuse squared. So we're going to get C squared equals, and I don't have a calculator with me, let me just put my phone on here. We need 17 times 17, so that's 289 minus 64, so we get C squared equals 225. And if you take the square root of both sides, you get C equals 15. Square root of 225 is 15. Okay, let's move down to 7. That was a bad one. 7. Okay, this one you're given points -6, 4, and 1, 2. So I'm going to just stick a graph in here. Bear with me for a second until I get my graph. I have graph paper that I can actually paste in there. At least I usually do. I don't know where it went. Hold on, I have to look somewhere else. So far since I started teaching this lesson, I've had 2 phone calls and a bunch of texts, and nobody ever calls me. Okay, here's our graph paper. So we're going to put the point -6, 4, 1, 2, 3, 4, 5, 6, -6. Now some of you didn't plot your points correctly. This is X, this is Y. So we're going to go -6 on the x-axis, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. That's your first point. And then 1, 2. And that would be our line. Now we'll connect those. Kind of a chubby line there. And then we're going to make a right triangle out of that. Remember this? So I'm going down 2 and I'm going over 7. So if we write our numbers over, this would be 2 and this would be 7 and this would be -2. So the first thing they ask is what the slope is. Remember, slope is rise over run. So we rose -2. We went down 2. So it's going to be -2. And we ran +7. So that's our slope. That's part A. Now we're going to find the distance, and we just need to use the Pythagorean theorem. This time we have both legs. So it's going to be -2 squared plus 7 squared equals our distance squared. So we're going to get 4 plus 49 equals the distance squared. And we're going to get distance squared equals 53, and there's no perfect squares. When we treat out, there's no friends. So we're going to get distance equals the square root of 53. And it's not going to be plus or minus. Normally when we take the square root of both sides, it's plus or minus, but it's a distance, so it's not going to be that way. Okay, you did okay on 8, but let me just run through it really quickly. The first one is f of x equals 3 plus the square root of x. Square roots always look like e. They look like this. Okay, the next one is f of g of x equals negative x plus 3 squared. If you have a squared, that means it's quadratic. If you have a negative in front, it means it's a frowny quadratic, frowny parabola. Okay, h of x is an absolute value. Negative absolute value of x minus 2. Absolute values, this is negative, so it's going to go down, always look like these. Remember that, absolute values look like these. And let's see, k of x. K of x equals negative x cubed plus 1. Cubic functions always look like a squiggle. This is a negative squiggle, so it's going to go downhill. So it's going to look like this one, downhill squiggle. And finally, p of x is x squared plus 3. This is quadratic because it has the squared term, but it's a happy parabola because it's positive. Okay, real quick on that one. Okay, some more problem areas. Let's hit number 9. Sorry that I'm doing speed version. If anyone wants to meet with me tomorrow during Compass, I'll be happy to go over your test with you. Alright, x squared equals 25. Now, this is just like when we were doing the distance problems. Let's go back up here. Remember this, we would have d squared equals 53, and we take the square root of both sides. It's the same thing, only this time it's not a measurement. So we're going to take the square root of both sides. We're going to get x equals plus or minus the square root of 25. Remember, if you take the square root of a square, so the square root of anything squared is just the original number. Alright, so we're going to get x equals, that's a perfect square, plus or minus 5. Let's hit another one of these. Y squared equals 80. Same thing, y equals plus or minus the square root of 80. But if we treat this guy out, we would get 40 times 2, 4 times 10, 2 times 2, 2 times 5. So if we tree that out, we have a pair of 2's and another pair of 2's. So 2 times 2 comes out, so that's going to be plus or minus 4, and the poor 5 is stuck inside. And then the final one for this C is, this one's even easier, z squared equals 7, z equals plus or minus the square root of 7. There's no simplifying with that one. Okay, 10. You're just moving right along here. 10. This one was a factoring problem. Most of you actually got this one partially right, but not many of you got it the whole way right. X squared minus 5x. You're trying to skip too many steps. Okay, I'm going to flip it right away. X squared plus 9x plus 18 all over x cubed minus x squared minus 42x. Okay, when it's division, you flip it. So I already flipped it, and now I made it multiplication. Now we're going to, let me just erase that. Now we're going to factor. And you can factor right above. I'm okay with that. So just to start anyway, because this is, oops. This is my third phone call. Hold on a second, I'm not starting this over again, it's Noah. Hey Noah. Yeah, Josh is on his way. Alrighty. Okay, alright, bye-bye. Okay, sorry about that. Okay, now we're gonna start factoring it. Here we can take out, and if we factor this one, it's gonna look like this. X, what times what gives you x squared? What times what gives me 15? It's 3 and 5. And when I subtract them, I get negative 2. Or when I add them, I get negative 2. So we need the bigger one to be negative, positive. This tricked a lot of you. You want to take an x out of there, so you get x minus 5. Here we get x and x. What times what gives me 18? and when let me make sure I copied that down correctly, and when I add them together I get 9. Well, that would be 9 and, okay, 6 and 3. 6 and 3. And then finally, this one's a double stepper, so I'm going to take out an x first, x squared minus x minus 42, and then I'm going to keep going here. You know what, I didn't flip that when I wrote it down. Well, that's really bad. So x minus 7, x plus 6. Okay, so this is division yet. I didn't flip it yet. So I'm going to clean it up here. X plus 3 times x minus 5 over x times x minus 5. Now I'm going to flip it. X times x minus 7. Usually when I copy it down I just flip it, but I didn't flip it that time. X plus 6, x plus 3. Now we cross out, we have x minus 5's cross out, the x plus 3's cross out, the x plus 6's cross out, the x's cross out, and you're left with x minus 7. Okay, 11. Solve by factoring. Okay, 11. Solve by factoring. 36 equals x squared minus 5x. This guy is quadratic, which means in order to solve it you need to set it equal to 0, and you actually need to get numbers for x. You're usually going to get 2 different answers for this one. So it's to set it equal to 0, I need to bring him over there. So we're going to get 0 equals x squared minus 5x minus 36. Hopefully this guy factors, so we get 0 equals x, 9, and 4. We want it to be negative, so we need to make the bigger one negative, the smaller one positive. Now we have 2 factors. If either of these factors are 0, the whole thing is going to be equal to 0. So either x minus 9 equals 0, or x plus 4 equals 0. X is going to equal either 9 or x is going to equal negative 4. You need answers. You cannot leave it in this form, which some of you did. Some of you didn't set it equal to 0. So if it's quadratic, you set it equal to 0, especially if it says solve by factoring. Okay, 12 was a bad one. 12. Here we go. Trying to speed do this. F of x equals 2x minus x squared plus 3. This is a tricky problem, I admit. F of x minus 4. So most of you did pretty good. You put x minus 4 in for all the x's. So we get f of x minus 4 equals 2 times x minus 4 minus x minus 4 squared plus 3. Okay, you did that. That's pretty good. Now we have to work it out. So we're going to distribute 2x minus 8 minus, now here's the tricky part, you have to FOIL this. This is x minus 4 times x minus 4 plus 3. So I'm going to keep going here. 2x minus 8 minus, whatever we get when we FOIL this, this negative sign has to be distributed the whole way through. So we're going to do first is x squared. The outer is negative 4, the inner is negative 4, so it's negative 8x. If we add those together, plus 16 plus 3. Now we distribute. You can see why this is a harder problem. Minus x squared plus 8x minus 16 plus 3. Now we just combine like terms. So we only have 1x squared, so it's negative x squared plus 10x. And then we have all these numbers going on here. So we have minus 24 plus 3 is minus 21. I'm thinking that's the right answer. Let me just check. Yes, okay. Let's move on now to a serious problem. Number 13. Hold on a second. I didn't know so many of you didn't know how to do long division. Let's see if we can learn it real quick. This one is x cubed minus x squared minus 1 divided by x minus 4. Okay, here we go. We're going to put the x minus 4. We have an x cubed minus an x squared. We don't have any x's, so we have to put our placeholder, 0x, or oxen, minus 1. Now we say, what times x gives me x cubed? We ignore the negative 4, so we say x squared. Then you distribute this through these two, this binomial. So you get x cubed minus 4x squared. Remember, we change our signs and we add it straight down. These should always cancel each other out. 4x squared minus x squared is 3x squared. And we bring down the 0x. And we start all over again. We say, what times x? We only care about this guy when we're determining what to put up here. What times x gives me 3x squared? And it's going to be 3x. Now we distribute this one through both of those. So we get 3x times x is 3x squared. See how they match exactly? 3x times negative 4 is negative 12x. Make that negative, this positive, and we get 12x. And we bring down the negative 1 and we start all over again. What times x? Remember, we only care about him. What times x gives me 12x? That's going to be plus 12. 12x times x is 12x. 12x times minus 4 is negative 48. Change our signs and add, and we get 47. That's our remainder. So we put the remainder over the divisor. And that's your answer. So hopefully that cleared things up. Okay, 14. Solve x over 6 minus x plus 2 over 4 equals 1/3. Remember, if it's an equal sign, we can get rid of our denominator. We look for the common denominator, it's 12. I'm just going to put this here. We're going to multiply everybody by the common denominator. Okay? The 6 goes into 12 2 times, so we get 2x. The 4 goes into the 12 3 times, so we get 3. Notice I put parentheses around the binomial. That's so that I remember to distribute. So we get x plus 2. 3 goes into 12 4 times, we get 4. Now we're going to distribute. See this negative sign? It has to distribute over to that 2. So we get 2x minus 3x minus 6 equals 4. Minus x equals 10. And then we divide both sides by negative 1. Remember, I added that 4 over there. So we get x equals negative 10. Okay. 15. You can always stop the video and stare at a problem longer if you're not getting it. Solve by graphing. Another scary problem. Y equals negative 2x minus 3. Y equals negative x plus 1. Remember, let me get a graph again. Oops, I should go get the graph a little bit faster, maybe. Okay. Graph paper. Okay, here's our graph paper. So let's do the first line in red. Okay. Hopefully that make it red. Okay, red. So y-intercept is negative 3. Remember, we got y equals mx plus b. B is your y-intercept. You put a point on negative 3. Your slope, remember that's your slope. M is slope, and it's always, you make it a fraction. It's rise over run. So we start at negative 3, we're rising negative 2, and we're running 1. So we got it right there. I'm going to connect it with a line, best as I can, better than I do in class, I guess. Okay, now I'm going to do a blue line. Make that one blue. So our y-intercept this is our B, this is our y-intercept. Whoops, my whole line turned blue. Darn. Okay, my y-intercept is 1, so I'm going to put a point on 1, and my slope is 1 over 1. It's negative 1 over 1. So I start at the y-intercept and I go down 1 and to the right 1. Now this problem's a little challenging because it doesn't really intersect where we want it to, because we can't really see where it intersects. So we might have to extend our lines a little bit. So we're going to connect our points like that, and this line we can extend up like that, I guess. And let me just get another line here. Let's go back to having a red line, and we'll have to extend this guy, and they're going to intersect somewhere up there. So you're going to have to look at your graph. You're going to have to extend it a little bit better than I did. And if you look at your graph, it's going to intersect at negative 4, 5. Of course, my graph does not look like it intersects there. Down 2 over 1, 1, 1. I don't know why it doesn't intersect there. But your point should be negative 4, 5. 1, 2, 3, 4, 5. Negative 3, 1, 2, 3, slope down 2 over 1. So I'm not sure why that didn't intersect there. Okay, let's go to 16. Okay, 16 was your scientific notation. 600 times 10 to the 6th times 0.0007 times 10 to the 8th all over 700,000 times 10 to the negative 12 times 0.0004 zeros and a 3. Okay, first we're going to put these in scientific notation, which means the decimal point goes after the first non-zero digit. So we're going to get 6 times 10 to the 8th. So we're going to move it 2 places to the left, so we actually add 2. This is going to be 7 times 10. We're going to move it over 1, 2, 3, 4. So we're going to subtract. We're going to subtract 4 from 8. So it's going to be to the 4th. This one's going to be 7 times 10 to the 1, 2, 3, 4, 5. So it's going to be 10. We already have negative 12. We're going to add 5 to that. So it's going to be to the negative 7. And then finally it's going to be 1, 2, 3, 4, 5. So it's going to be 3 times 10 to the negative 5. Now once we get it like that, we're going to multiply. We can multiply our numbers together. 7 times 6 is 42 times 10 to the 12th. We add our exponents, and now on the bottom we have 21 times 10 to the negative 12. 21 goes into 42 2 times, so we get 2 times 10, and if we bring this up it becomes positive, 10 to the 24th. Okay, sorry that I'm rushing so much, but I know I don't want this to be too long. Okay, 17, bad problem. Whew. So let's take our time on this one. Negative 4 square root of 3 times the quantity 6 square root of 12 plus 2 square root of 21 plus the square root of 70,000. Radicals have really been a problem this year. They're kind of fun. They're supposed to be fun. So we're going to distribute first. This times this, and this times this. You did pretty good with the distributing. So you get negative 24 square root of 36 minus 8 square root of 3 times 21 is 63. And then this big bad boy over here. Let's tree him out a little bit. It would be 7 times the square root of 10,000. These two together give you that. Okay? The square root of 36, this guy here is a perfect square. Remember perfect squares? We have 4, 9, 16, 25, 36, 49, 64, 81. If you see one of these, the square root of 4 is 2, the square root of 9 is 3, square root of 16 is 4. So this is going to be negative 24 times 6. That was easy. Now this one here has, you can tree it out if you want to. You get 9, you get, 9 times 7, 3 and 3. Okay, there we go, that's what comes out. So let's move down here. Negative 24 times 6 minus 3 times 8 is 24, square root of 7, plus the square root of 7. Remember, we take half our zeros, and it comes out when you take half the zeros. Ruh-roh, my pen's going crazy here. So that would be times 100. So let's just multiply this out. We're going to get negative 144 minus 24 square root of 7 plus 100 square root of 7. And then when we simplify this, we can add, we're going to get negative 144, and then when we add 100 minus 24, we're going to get plus 76 square root of 7. Now remember, this can be simplified. When you take a square root with even zeros, you get half the zeros and it comes out. It doesn't stay under the radical anymore. Okay, 2 more and then we're going to be done. We're not going to do the last one. Okay, 18, graph the inequality. Negative 4 is not greater than negative 4x plus 8, and the domain is the integers. So let's first of all take care of this. So you get negative 4. If it's not greater than, then it's going to be less than or equal to negative 4x plus 8. Let's subtract 8 from both sides. Okay, so we get negative 12 is less than or equal to negative 4. Divide x, divide both sides by negative 4. Remember, when you divide by negative, your inequality sign has to flip. So now we're going to get 3 is greater than or equal to x. Or let's put the x first. X is less than or equal to 3. So we're going to do this. We're going to put a 3 here. It's integers, so we're only going to put dots on our integers. And you can put as many as these as you want. That's probably enough. And you fill in the arrow that we're going to keep going, going, going. So keep in mind, integers are dots. And when you divide by a negative, you flip your inequality sign. Okay, last one is Pythagorean theorem. Same thing again. 5, 9x. Remember, it's leg squared plus leg squared equals hypotenuse is opposite the right angle, hypotenuse squared. So you get x squared equals 9 squared is the 81, and I'm going to subtract the 25 from both sides, minus 25, so we get x squared equals the square root of 56. Let's take our 56 and tree it out. Let's see, it's 2 times 56 over 2 is 28. I didn't really need to do that, did I? 2 times 14, 2 times 7. So your 2's come out, so you get x equals the length, so we don't need the plus or minus, 2 times the square root, and these guys are trapped. 2 times 7 is 14, and that's your final answer. Okay, sorry for such a long video, and if you look at it tonight, then you can ask me questions at Compass tomorrow. So, hope that helped.